Why algorithmic assets are replacing static design files. For decades, digital design ecosystems have been built around a single fundamental assumption that the primary unit of value is a static file. CAD models, meshes, drawings, and exports have served as the dominant medium through which design intent is stored, exchanged, and manufactured. This paradigm, while sufficient for linear workflows, reveals significant limitations in contexts that require scalability, variability, and automation. Parametric distribution represents a structural departure from file-based thinking. Instead of distributing finalized geometric artifacts, platforms such as BeeGraphy introduce a model in which the core asset is executable design logic. In this paradigm, geometry is no longer the product. It is a temporary outcome generated on demand from a defined algorithmic system. A static design file encapsulates a single resolved state. Any modification, dimensional, material, or structural, requires manual re-entry into the modeling process. This creates a dependency loop between design, validation, and production, significantly increasing time to market and the likelihood of errors. Parametric distribution replaces this approach with systems that describe how a design behaves rather than what it looks like. Design intent is formalized as a set of parameters, constraints, and relationships that collectively define a solution space. The file becomes a derivative artifact, generated only when required and discarded afterward if necessary. This shift mirrors transformations previously observed in software engineering, where compiled binaries gave way to reusable, configurable source code. In parametric design, algorithms play a similar role to software libraries: reusable, adaptable, and scalable. In a parametric distribution model, what is exchanged between creator and user is not a shape, but a bounded computational system. The designer defines the rules, limits, and dependencies that govern variation. The user interacts with these rules through controlled parameters, operating the system without altering its internal logic. This approach fundamentally redefines ownership and usage. Instead of purchasing a single design instance, users gain access to a generative mechanism capable of producing numerous valid outcomes. Each configuration remains consistent with the original design intent while adapting to contextual requirements such as size, material, or production method. As a result, value shifts from individual files to the robustness and expressiveness of the underlying algorithm. Traditional digital marketplaces are optimized for cataloging static assets. Search, preview, licensing, and pricing mechanisms assume a one-to-one relationship between product and output. Parametric distribution challenges this assumption by introducing one-to-many relationships, where a single algorithm can generate thousands of distinct yet valid products. This necessitates a new class of marketplaces, not repositories of files, but platforms for distributing executable design systems. In such environments, interfaces prioritize parameter control, real-time validation, and production-aware output rather than simple downloads. The marketplace itself becomes an execution layer, not merely a storage layer. One of the most significant advantages of parametric distribution lies in its economic implications. In traditional workflows, customization scales linearly with design effort. Each variation incurs additional cost. Parametric systems invert this relationship. Once the algorithm is authored and validated, the marginal cost of generating a new variant approaches zero. This enables true mass customization, products tailored to individual needs without proportional increases in engineering labor. For manufacturers and designers alike, this represents a shift from project-based economics to system-based scalability. Parametric distribution marks a transition from static representation to dynamic execution in digital design ecosystems. By treating algorithms as first-class assets, it dissolves long-standing barriers between design, customization, and manufacturing. Rather than distributing shapes frozen in time, platforms adopting this paradigm distribute intent, logic, and capability. In doing so, they redefine not only how designs are shared, but how value is created, scaled, and sustained in the era of computational manufacturing.